Okay, taking yet another example for normal reaction force. See, here gravitational force is not playing a major role. See, this is a mass small m, this is the mass capital M, and the mass capital M is pushing small m. It is pushing small m so that the mass gets an acceleration a. ओके बड़े एम ने छोटे एम को पुश किया ताकि फोर्स लगाया उस पर और कितना फोर्स लगाया ताकि उसका एक्सेलरेशन कितना हो जाए. द एक्सेलरेशन मस्ट बी इक्वल टू ए. ओके अब ये कौन सा फोर्स है जो कैपिटल एम ने स्मॉल एम पे लगाया है? ये नॉर्मल फोर्स है. नॉर्मल रिएक्शन फोर्स आई एम नॉट सेइंग, इट इज नॉर्मल फोर्स. ओके सच एज इफ यू आर पुशिंग ए कार है ना, कभी कभी कार बंद हो जाती है, बैटरी खराब हो जाती है, तो व्हाट आर वी सपोज टू डू? वी आर सपोज टू पुश द कार. सपोज टू पुश द कार. विच फोर्स वी आर अप्लाइंग ऑन द कार? वी आर अप्लाइंग ए नॉर्मल फोर्स ऑन द कार. ओके अब या फिर when you actually push the car, you will see that the car is not getting pushed, but it is applying a reverse force on your body. That is what force? That is the normal reaction force. The force which you are applying is normal force, and the force which the car is applying to you, on you, is normal reaction force. Okay, I will explain this. The force applied by capital M on small m will be in this direction, and that will be normal force. Okay, for every action force there is a equal and opposite reaction force. So small m also applies some force on capital M in the reverse direction. What will be that? That will be normal reaction force. Okay, so now how to calculate this normal force or normal reaction force? See, what is the acceleration of the object? The acceleration of the object is equal to A. Acceleration is equals to A. Okay, so what is the net force acting on the body small m? ठीक है, देखो एक बॉडी है स्मॉल m, उसका एक्सेलरेशन कितना हो रहा है? A. ठीक है, तो उस पर जो टोटल फोर्स लग रहा है वो कितना है? F इज इक्वल्स टू ma. ओके अब देखो ये जो नेट फोर्स एम लग रहा है, ये कौन लगा रहा है? ये कैपिटल एम लगा रहा है स्मॉल एम पे. So what is that force? That is the normal force. So what is the normal force applied by capital M on small m? That is m into A. यहाँ पे gravity नहीं है. Okay, this is applied force. Okay, now if I ask you what is the normal reaction force which is applied by small m on capital M? It will be equal and opposite, so that will also be equal to ma. Did you get this example? Very nice if you get this. We move to the next example now. Now see, before we move to the next example, there is something very important to learn. This is the the most important topic, one of the most important topics in physics that you will require every now and then. इसकी जरूरत हमेशा पढ़ने वाली है. What is the topic? The topic is a free body diagram. What is it? It's the free body diagram. Why do we draw free body diagrams? Because we want to have a clear idea about the operation of forces. Forces operate करते हैं, उसका क्या इफेक्ट होगा, फोर्स कहाँ से आया है, और किसी बॉडी पे नेट फोर्स कितना लगेगा. टू नो ऑल दिस वी हैव टू ड्रॉ फ्री बॉडी डायग्राम्स. नाउ व्हाट इज हैपनिंग इन फ्री बॉडी डायग्राम? स्टेप बाय स्टेप. नंबर 1, डू नॉट शो द बॉडी विद द एक्चुअल साइज एंड शेप. हो सकता है आपका बॉडी सिलेंड्रिकल शेप का हो, स्क्वायर शेप का हो, रेक्टेंगुलर शेप का हो, क्यूबॉइड हो, व्हाटएवर इट इज. जस्ट फॉरगेट अबाउट द साइज एंड शेप ऑफ द बॉडी. जस्ट रिप्रेजेंट द बॉडी बाय ए स्मॉल पॉइंट. Okay, just represent the body by a small point. बताता हूँ कि कैसे इसको करते हैं. Suppose there is a body and whatever the size and shape is, I represent it by a small point. Okay, second point, draw all the forces on the body. जितने forces आपको पता है वो सारे body पे बना दो. Okay, एक तो सबसे easy and सबसे clear force, that is the gravitational force which will be acting on the body. ठीक है, Fg. अच्छा, दूसरा, if the body is in contact with one surface, if it is in contact with the earth, then earth will apply a normal reaction force on the body in upward direction. Okay, अच्छा, suppose if some person is coming and pushing that body in some direction, then that force also has to be drawn. Okay, if some person is standing on the other side and applying force on the same body, then that force also has been drawn. Okay, now in spite of that, if the body is connected to some string and the string is pulled, then the body will also experience that pulling force. Then that force also you have to draw. मतलब जितने forces पता है सारे के सारे बना देने के. Okay, resolve the forces if required. How you know how to resolve the forces? Into cos theta component and sin theta component. So if required, you have to resolve. Now अभी सर हमको कैसे पता चलेगा रिजॉल्व करना है नहीं करना है बेटा, ये दिस थिंग्स विल you will be learning by practice. When you were born, you didn't know how to walk and you used to wonder, everybody is walking, why I'm not able to walk. Then you practiced and then you were able to walk and you were able to run. You were able to jump also. Okay. So how you will know that I have to resolve it, or I don't have to resolve it, or I have to keep it as it is, I have to make changes? Practice will teach you everything. Okay, no teacher can do that thing for you which your own experience can do. Okay, now resolve the forces required. Next, draw acceleration of the body. Okay, now there are about 1, 2, 3, 4, 5 forces acting on this body, and due to all that, if suppose the acceleration of the body is in upward direction, then you draw this acceleration vector like this. Okay, and after drawing the acceleration vector, use the expression net force is equals to sum of all forces. What I'm doing, I'm trying to find the net force on the body. Now, how much forces are actually acting on this body? There are 5 forces. So if I add all these 5 forces, 1 force, 2 force, 3 force, 4 force and 5 forces, and then I will get the resulting force on that body. And that resulting force on the body will always be equal to mass into acceleration, m into a, resulting force. Okay. The students sometimes get confused that F is equals to ma. Every force is equals to ma. No, every force is not equal to ma. ये जो F is equals to ma न्यूटन ने कहा है, जो हमने जो conclusion निकाला है, that F is equals to ma, it is not for every force. It is only written for the resulting force on the body. It is only the resulting force on the body. So m is mass of the body, a is acceleration of the body, and what is F? F is the net force acting on the body. It is always the net force which is written as m into a, mass into acceleration. Clear with this? Every force is not equal to ma. It is the resulting force, the net force, which is equals to m into a. Okay, the next thing, sign convention is very important. Sometimes you have to give plus sign, sometimes you have to give minus sign. Okay, and the last thing that sometimes you can write all the x, y and z directions in the same equation, and sometimes you will have to use different equation for x, different equation for y, different equation for z. Clear? This is the free body diagram. And based on this free body diagram, we write all these points. This is very helpful. Okay, based on this free body diagram, we'll be learning some more concepts for normal reaction force. Okay, now take a look at this. Here I have 3 bodies instead of 1. It's body M1, body M2 and body M3. Okay, and they are all moving with acceleration a. M3, M2 and M1, they are all moving with acceleration a. Now the first thing I'm going to do, force on M3, the total force on M3, what it will be? Suppose there are many different forces, about 1000 forces acting on body M3, but what is the resulting force acting on M3? It will be M3 into a. The resulting force on this will be M3 into a, which is applied by M2. ओके अभी ग्रेविटेशनल फोर्स और ये फोर्स वो फोर्स सारे हैं, लेकिन जो एक्सेलरेशन होगा बॉडी M3 का, उसके लिए जो फोर्स लगा रहा है वो कौन लगा रहा है? इट इज बॉडी M2 विच इज अप्लाइंग फोर्स ऑन M3. क्लियर? सो व्हाट इज द फोर्स बिटवीन M2 एंड M3? Very simple. The force between M2 and M3 is equals to M3 into A. Did you get that? It takes time and it takes more repetitions to learn this. If you understood in the one go, it's good. If you don't understand, you have to go through many times to understand that the force between M2 and M3 is M3 into A. Similarly, what is the force applied by M3 on M2? अभी M2 ने M3 पे कितना फोर्स लगाया, M3A, तो M3 M2 पे कितना फोर्स लगाएगा, एक्शन रिएक्शन पेयर बनेगा ना, तो दैट विल ऑल्सो बी M3 into A. ठीक है. नाउ let us try to find out what forces are acting on M2. What forces are acting on M2? तो M2 पे जो forces हैं वो कितने होंगे? For that we will be drawing free body diagram. Okay, so I'm using a small point, and this point is the mass M2. What is it? It is M2. Clear? Now we draw all the forces. जितने हम जानते हैं सारे forces बना देते हैं. One is the direction in downward, that is gravitational force. ये कितना होगा? M2 into G. There will be a normal reaction force in upward direction, that will be N. ठीक है. Now N and M2G will be equal. ये कौन सी direction है? This is Y direction. Clear? And the other thing, there will be some force by M1 on M2. M1 भी M2 पे एक फोर्स लगाएगा, that will be in this direction. और M3 भी M2 पे एक फोर्स लगा रहा है ना. क्यों लगा रहा है? क्योंकि M2 ने M3 पे फोर्स लगाया, एक्शन वाला, तो M3 M2 पे एक फोर्स लगाएगा, रिएक्शन वाला, that will be in this direction. Okay, so these many forces are acting on the body. Now we are interested in calculating what is the force applied by M1 on M2. Okay, so we are not interested in vertical forces. We'll be considering only the horizontal forces. तो ये vertical forces जो हैं, ये वाला upward and this downward, इसको मैंने हटा दिया, and I have drawn only two forces. One is N12, the force applied by body M1 on body M2, and another force which is N23, which is force applied on body 2 due to body 3. Okay, so these two forces, and अभी क्या करने का, ये free body diagram बनाया. Now we have to draw acceleration. What is the acceleration of body M2? It is equals to A. Clear? So one horizontally right side, one is horizontally left side, and the net resultant force on body M2 is equals to M2 into A. समझ में आया? The resulting force on M2 will be M2 into A. This force, net force. And what is net force equals to? Net force equals to sum of all the forces. जितने भी forces horizontal direction में work कर रहे हैं उन सबको यहाँ लिखना पड़ेगा. ठीक है. तो अब देखो साइन कन्वेंशन यहाँ पे कैसे आता है. What is direction of acceleration? It is towards the right side. So the forces which are acting on the right side, I will take them positive. Okay. Direction of acceleration is towards this side. So whatever forces are acting on this side, I will take them as positive. So ये force N23, it becomes negative because it is on the opposite side. And this force N12, this becomes positive because it is acting in this direction. Clear? So I'm using the same sign convention. ठीक है ना. जिधर acceleration हो रहा हो उस तरफ वाला force या उस तरफ वाली जो भी चीजें हैं, they are considered positive. उससे opposite जो भी चीजें हैं, they are all considered as negative. So N12 minus N23. Now I'm calculating N12. ठीक है. Now N23 को इधर transpose करो and this and that, and what you will get? You will get the value of N12. M1 plus M2 into A. Okay. It's complex, no? It is complex. You have to think, you have to act, you have to think a lot. You have to go through the examples over and over again. You may have to solve many different examples to learn this normal reaction force. All right. So all the best. And in the next video, we'll be learning more examples about normal reaction force. It's not easy. We'll be doing a lot of examples to learn the normal reaction force.